Tom is the man behind the range. He is our director of engineering at Dragos, where he's responsible for ensuring that the Dragos platform is successfully deployed. He has extensive background in industrial controls and really enjoys getting into the field and making things work. Prior to Dragos, he held many roles focused on the operation, engineering, and security of industrial control systems. He began his career with the US Air Force, eventually retiring with a total of 24 years between active duty, reserves, and Air Guard. He spent the last half of his service on a national mission tour in a cyber operations squadron. Tom is a co-founder of the ICS Village, a nonprofit educational organization that equips industry and policymakers to better defend industrial equipment through experiential awareness, education, and training. He also consults with SANS on the construction and operation of cyber ranges. I can't think of anyone more qualified to take us through the range. Let's start by getting a little bit of background from Tom before he shows us the demonstration. Tom, maybe you can start by telling us what was the impetus for creating the range?
The reason I started creating these ranges about 6 years ago, I was co-founder of a nonprofit called the ICS Village. We needed something to take to DEF CON, the hacking conference held in Vegas every summer. And a couple of us got together and said, hey, it'd be great if we had real control systems to bring to that conference. That turned out to be very successful. That whole effort turned into what we have today, a whole legitimate nonprofit. Many organizations and universities have these ranges installed at their facilities now. But, the reason why it was really created is to give people a safe environment to learn how industrial control systems work. We wanted to provide people with access to real hardware. We read on the internet all the time about hacking PLCs and OTs and secure and all different kinds of other stories. Some of it's true, some of it's not. And we wanted to give people the opportunity to see what these things really are, what PLCs are and HMIs and industrial switches and things of that nature.
And maybe you could tell us a little bit about your process for creating it, how long it took, what types of people were involved in making this a reality.
A typical range, like we saw in the webinar advertisement, and we're going to see in the video here, they take about 12 weeks to build. It's certainly not just me building these. We have a graphic artist behind it. We have different people, that make up the piping, the tanks, and the things of that nature. It really is a pretty in-depth process. You look at it and you see a bunch of industrial control system hardware on there, but behind the scenes, everything's working, everything's communicating with each other. We have pumps and motors and valves and things of that nature that all have to work together. The complexity of them, really gets pretty deep, where everything gets funneled into a server where we can view that data that's being transmitted between the devices, and allows for a resilient network so people can connect to these and try different things and learn on them.
Why do you think the range is such a good environment to conduct real world testing?
You actually get to see everything firsthand. We have that cyber physical effect on it. The one here that we're going to see the video on, it just has water on it, and a lot of them have water because everybody can relate to that moving water and tanks overflowing. But the key thing here is it's a safe environment. Everybody can go up and look at them, touch them, log into the engineering workstations, make changes. And when you force that bit on, say for the pump, you can see the pump overflowing the tank. Now there's safety mechanism built in there, so if the tank does get too high, there's a safety switch that's hardwired into the pump to shut the pump off. But it gives people that opportunity to, hey, let's see what happens when I force this bit, or if I make that logic change, or if I don't turn something on. It works really well seeing the physical effect.
Can you comment maybe on what the impacts of threats are that could affect downtime?
Your threats come in many different ways. With here, you can simulate different threats. Just my previous example where you go and you force that pump on, or you force the pump off, or maybe you change that set point and your HMI is reading a 50% set point level, but your tank is really dry, or maybe your tank's overflowing. So you can simulate many different things. Also on these networks would normally have a northbound network with some kind of a business connection or some sort of external connections. So you can simulate threats coming into your network. This one here has a wireless connection into it. So we can simulate things that way.
Maybe help us understand how this range really supports the Dragos platform and helps strengthen it.
Here at Dragos, I work in the research and development department, and we use these ranges for building out our product, our analytics portion of it. So we can actually say, listen, we have these real controllers. We run analytics against them, and it really helps building in the stability of the product and the content of the product when we're using real hardware. And we see what happens to that, and we can build analytics off of it.
Does that apply to integrations as well?
Absolutely. So if you go on the dragos.com website and you look at the integration or the partners section of that, you can see there's Splunk there and many other ones, and absolutely we go and we get Splunk, for example, on here, and we integrate it with the platform, and we send malicious stuff to our controllers, but we also send good traffic to the controllers and the HMIs and network traffic, and see what shows up in the platform and how the integration is properly working between the Dragos platform and our various partners.
Any more insight into sort of what data is sent and how it's used?
A lot of the data that we're using and creating is real data that a plant would have. That data is very useful, so we can see what normal is. So we can go and see how it's supposed to work. So when we inject malicious data, we can then see what happens, how different things react.
Well, let's take a closer look.
The main reason why we build these is to give people an opportunity to see what real ICS components are, how they operate, how they integrate with one another to provide an output. On this range here, we are using water for the visualizations effects on this. Really connects with people when we see the tanks overflow, when we see things move and happen. We can hear the motor speed up and slow down. We see the level change. So water really adds that physical effect into our demonstration that we have. In the back, we have a tank of water, 3-phase pump back there that we pump water up through the front. We have a commonly found flow meter that sends a signal back to our PLC to display the value on our human machine interface. Then we have a temperature transmitter that reads the temperature of the water and feeds it back onto the human machine interface. We have industrial firewalls, we have industrial switches. They're a little bit different than your standard enterprise grade switches and firewalls. We have our industrial sensor. It's a computer, but it's hardened. It's not the normal computer you find on your desk. We make these ranges up to provide a safe learning environment for people to come in to find out what a programmable logic controller is, or a human machine interface is, or a variable frequency drive. These components aren't normally accessible to majority of the people. They're out in a lot of control cabinets, out in the field somewhere, and you're just not going to walk through your plant and open up a control panel and say, hey, I want to see that PLC. We use it for research and development purposes. We use it for learning. And in this case here, we're going to go around the world and offer training classes on control systems, how to secure them, how to defend them, threats against them, things of that nature. But the key thing is here, we're using real control systems. We're bringing that environment to you where you can say, hey, that's a PLC. That's a PLC. They're variable frequency drives. It definitely provides a unique learning environment.
I see a bunch of questions have come in. How adaptable is the range as technology changes?
All of our ranges that are built are made to be expanded in the future. We want to be able to have the ability to add older technology, because there's a lot of people that run the older type of PLC or the older type of control systems that we have to protect. But also we need to make it so we can continue to add newer technologies. We have a mix of both old and new, and we have the ability to expand as necessary.
Can the range simulate other industries?
Absolutely. The one that we're looking at here is a chemical plant or part of a refinery, meant to be. But some of these have building management systems, building automation systems, food and beverage, pharmaceutical, biotech. Since this hardware is used in virtually every vertical, exception of a few, but there's commonly found hardware, we can apply what we learn and see due to various industries.
Another question, can the hardware that's used be more customized?
It absolutely can be. This hardware is completely customizable. When these are built, it's really up to the customer to tell us what they want built with. If you're not an Allen Bradley facility, you're a Siemens, or you're a Navy B or Emerson or whatever it is, they will be built accordingly.
Do you consider the attack vectors when designing the rig, or is it something that just comes out naturally when you deploy it?
Little bit of both. Some of them come out naturally once we deploy and we start talking with the customer. Others are made, for strictly educational purposes, like this one here. Well, not necessarily this one here. This one here we're going to take around the world for our training, but it all depends on the purpose of it. If it's strictly for training, you're geared more toward how these systems go together, with some emphasis of the attack vectors. Other times we want to learn about the attack vectors, so it's more geared toward that. So it really depends on the purpose of them.
Another question about the energy segment, and the question is, what kind of network attacks and pen testing tools should we be familiar with if we want to focus on ICS or energy distribution in general? Are there any concrete examples of attacks and tools that you might recommend?
The different attacks, the MITRE framework just came out. It's a perfect, it's a great place to start. Tools, when you talk about pen testing real or active control system networks, that gets pretty difficult. I'd rather not recommend any tools on a webinar, not knowing who answered it or who asked it and why they're asking it. You can really cause serious damage and loss of life and environmental.
Understood. Is virtualization an option for setting up components in an ICS range?
Absolutely. So all of the engineering workstations are virtualized for this. We do have a considerable amount of virtualization on here.
Do you inject the malicious data through a connected IT system?
We can, absolutely. It all depends on what we're trying to teach and what we're trying to show, but that is a very realistic attack vector. Can
you recreate and learn from real life incidents like Ukraine power plant attack?
Yes.
How about the architecture? This is a question about, will they only need, how many sensors would be needed?
For these portable ranges, we only use one sensor for that. It's really a limitation of shipping and where we're trying to show how these things are put together. We like to show as much as we can, but sometimes we have to limit on what we can show. So we're only using one sensor here.
There's sort of a lot of interest. There was a question about if you would publish a white paper on how you built the range. I can tell you that we are taking this range on the road, and we have road shows scheduled over the next year, and we'll show you the link to that so you can see on our website in case you're interested in coming to a road show and actually seeing the range up close. Are the firewalls that I saw on the range used for segmentation only, or segmentation with flow control?
The firewalls here are purely for segmentation.
Is there a capability included as part of the range for attack through the remote access?
Yes. So some of the things that we show or demonstrate are a couple of different attack vectors, whether it be from external, from internal, and you can see that the tank overflow, you can see the tank drain, you can see the HMI doing different things. But yes, it is important to show what you can see, both internal and external.
Here's the link to our website where you can see our whole schedule of road shows. Next question. What protocols are you using? And are you using any CP?
So the protocols on this range here, we're using Profinet. We have remote I/O that talks Profinet back to our PLC, to our controller. We're using Modbus TCP, Ethernet IP. We have the capability to use a OPC UA. Right now, we have not included that in there, but we have really probably a half dozen or so industrial protocols. When these are designed out, I try to maximize the type of popular protocols that one would see, so they can see the difference between a Profinet packet and a Modbus packet, and the complexity between them both, and why one's so basic, and you look at a Profinet packet, and they're very complex with a lot of information going on there.
Okay, when you're choosing a scenario, what factors do you take into consideration?
We try to stay more basic with the scenarios for a couple different reasons. One, we're usually doing them live, and those of us who've done live demos before know that, hey, the live demo here is a high probability of not working. The other reason we try to keep them more in the basic end is that they show very well to the audience. When we want to show, hey, what happens when you pick up that USB in the parking lot that you found and you put it in your computer? What happens? They may have some code and it'll shut off the pump or turn the pump on, things of that nature. We can go more complex and replicate an activity group. One of the groups that we report on, that works also, but we try to really keep the attacks more basic to add that learning effect without going through a very large, many-step campaign.
Can the range support Modbus using proprietary TCP ports like 1234 and 70,000?
Absolutely, we can change it from port 502 to another port.
Another question: what were your challenges with using water and electronics in such a small space?
Keeping everything dry. I've been doing this for about 6 years now. I've run, most recently, just a couple weeks ago, I ran into my first issue. We're from the Northeast, and it's been a pretty mild winter, and I guess I did not drain the heat exchanger on my one display completely. I wasn't too worried about it because it's been a very mild winter here. Well, I filled up with water a couple weeks ago, turned it on, and my heat exchanger was busted. Unfortunately, I didn't realize it was broke until the water came out of my switch. It needs to say it was a very bad night to get the thing working again. Yes, you do run into those issues. There are safeguards, engineered in here for that. We have catch pans for the water. We have level switches and things like that. In my recent case here, it froze. If a company puts one of these in their building, I would hope the building doesn't freeze so they wouldn't experience that. Ours was, we had one issue over 6 years, so I think we're doing pretty good.
Good track record. Another question: what is the voltage on the electric motor, and how many amps does the range draw?
Fully powered, the range is just under 10 amps. Started a little bit more, but we're running is about 8 to 10 amps. The motor is a 3-phase 208 motor in the back. It gets a 3-phase power from the inverter on the front of the range. So that's 110 volts in. That VFD will convert that up to 3-phase 208. The motor is a 1/2 horsepower motor, so we're under 1 amp.
Why not implement protocols like IEC 60870-5-104?
Great question. So we absolutely can. We wanted to make this range fit many different industries. If we go and implement DMP3 or some other energy-related protocol, we're really locked into where we can go with this, or the audience. We wanted it to be used for many different places. In the office, we do have a power range, where we have a lot of the 61850s and DMP3s and stuff like that running on it. But for this one here, it had to meet a wider audience.
Thank you, everyone. Thank you, Tom. I hope everybody enjoyed seeing the range and having a chance to ask your questions to the range builder. Please take a look at our website to see where the range is going to be next at our ICS Roadshow. Thank you.